Chapter 2.4, the cosine law. What happens if we don't have a right triangle and we also don't have an angle and an opposite side? Looking at the two examples below, the left one we have an angle and we have the two sides adjacent to that angle. We don't have any pair, so we can't use the sine law, and it's not a right triangle, so we can't use our primary trig ratios or Pythagorean theorem. Looking at the second one, we have all three sides and no angles. It's not a right triangle, so again, we can't use primary trig ratios or Pythagorean theorem. And we can't use the sine law in either of these examples. So what do we do instead? We have the cosine law, which is also for oblique triangles, which means non-right triangles. There's two forms of the cosine law. The first one is to solve for a side length, and it is a squared equals b squared plus c squared minus 2 times b times c times cos of angle A. And you should notice in this equation we're solving for A, and we have cos of angle A. So this is the angle across from the side we're solving for. The other form of the cosine law is for solving for an angle. And it is cos A equals b squared plus c squared minus a squared, all divided by 2bc. We're solving for cos A in this equation, and notice that side A is in the subtraction location on the top of the fraction. So this is the side across from the angle we are solving for. Okay, let's practice. We want to find side B. We have the angle across from side B, and we have the other two sides. So in this case, I want to write my formula as b squared. If I was to rewrite the cosine law formula where I'm solving for a side length starting with b squared, then I would have b squared equals a squared plus c squared minus 2ac, and then cos b. Because I'm solving for side b, then I have cos of that angle. Then if I plug in my values, a is 59 and c is 48, although the order of those two doesn't actually matter. I have b squared equals 59 squared plus 48 squared minus 2 times 59 times 48 times cos of angle B, which is 47. And from this point, it's pretty easy. I just need to plug all of that into my calculator. I'm going to put it all in at once. There's just less chance of making an error if I do it all at once. So 59 squared plus 48 squared minus 2 times 59 times 48 times cos 47. Double check it. 59 squared plus 48 squared minus 2 times 59 times 48 times cos 47. Looks good. Hit enter, and we get 1922.1612. Okay, so we want b, and this is b squared. So we're going to take the square root of both sides, and that gives us b equals second function square root, second function answer. Enter 43.84. And usually we round side lengths to the nearest tenth, so we'll do that. B equals 43.8. Next one, find angle R. We're looking for this angle. We have the side across from that angle, and we have the other two sides. So we can call the side across from that angle side A, and then the other two sides B and C, and then angle R would be our capital A in our formula. So looking at the formula for solving for an angle, cos A equals B squared plus C squared minus A squared divided by 2BC. Now I'm going to plug in my values. Cos A equals B is 41 squared plus C is 37 squared minus A 51 squared, all divided by 2 times B, which is 41, times C, which is 37. And then again, just put all of that into our calculator. I want brackets around the numerator, so bracket, then 41 squared. Since it's not a negative 41, I don't need to put brackets around the 41. And then plus 37 squared minus 51 squared. Close the bracket, then divide by brackets around the denominator, 2 times 41 times 37. Close bracket, enter. We get cos A is 0.1479 ... That's cos A, that's not A. We want angle A. We need to do the cos inverse of 0.1479 ... So in our calculators, second cos, second answer, enter. We get angle A equals 81.4895 ... So angle A, which is really called angle R in this case, angle R equals, round to the nearest whole number for angles, so 81 degrees. Let's try some word problems next. The first thing we should do is write down the cosine law for solving for a side and for an angle so that we have them. Let's put those at the top of our page. Solving for a side, the formula is a squared equals b squared plus c squared minus 2bc times cos of angle A. And solving for an angle, we have cos angle A equals b squared plus c squared minus a squared divided by 2bc. First question, Nina wants to find the distance between 2 points, A and B, on opposite sides of a pond. She locates a point C that is 35.5 meters from A and 48.8 meters from B. If angle C is 54 degrees, find the distance AB to the nearest tenth. So just start by drawing an oblique triangle. It doesn't really matter what it looks like or if the angles inside look to scale. Then label your triangle. This triangle is called ABC. Start at one of the corners, label it A, and then move to the next, B, next, C. The side across from angle A would be side A, side across from B is side B, side across from C is side C. So it says she locates a point C that is 35.5 meters from A. So the distance between C and A is 35.5 meters. C to A, that is side B. Side B is 35.5 meters. And then it says, and 48.8 meters from B. So the distance from C to B is 48.8 meters. Distance from C to B, that is side A. Side A is 48.8 meters. Then it says if angle C is 54 degrees, find the distance AB to the nearest tenth. So angle C is 54 degrees, and we want to know the distance from A to B. Distance from A to B is side C. So we're solving for side C. We don't have a pair, so we can't use the sine law. It's not a right triangle, so we can't use Pythagorean theorem or the primary trig functions. So then we go to the cosine law. We're solving for a side, so it is the a squared equals formula. This time we're solving for C, so we can rewrite it so that it says C squared equals. Then it would be A squared plus B squared minus 2AB cos of the angle opposite the side we're solving for, which would be angle C. Then we plug in our information. C squared equals A squared is 48.8 squared. B is 35.5 squared minus 2 times A, which is 48.8, times B, which is 35.5, and then times cos of angle C, which is 54 degrees. Plug that into the calculator. (48.8 squared plus 35.5 squared minus 2 times 48.8 times 35.5 times cos 54. Double check it. 48.8 squared plus 35.5 squared minus 2 times 48.8 times 35.5 times cos of 54, and we get 1605.1316. C squared equals 1605.1316 ... That is C squared, but we don't want C squared, we want C. So we square root both sides. Second square root, second answer, we get 40.0640 ... Round to the nearest tenth for side lengths, so 40.1, and this was in meters. Next question. A triangular brace has side lengths 14 meters, 18 meters, and 22 meters. Find the measure of the angle opposite the 18-meter side to the nearest degree. Again, just draw an oblique triangle. It doesn't really matter if it looks to scale or not. So our three sides are 14. I'll go with this side being 14. It looks maybe the shortest. Then 18 meters, and then 22 meters. It says find the measure of the angle opposite 18 meters. So that would be this one. So we can call that angle A. Then this is side A, and the other two are sides B and C. It doesn't really matter. That would make this angle C and this angle B. We want to find angle A to the nearest degree. Again, we can't use sine law because we don't have a pair, and it's not a right triangle, so we can't use Pythagorean or the primary trig ratios. So we're going to use cosine law. Let's take a look at what our equation is. Cos A equals b squared plus c squared minus a squared divided by 2bc. I labeled the angle I want A so that I don't have to change the equation. Cos A equals b squared plus c squared minus a squared divided by 2bc. Plug in your information. Cos A equals 22 squared plus 14 squared minus 18 squared divided by 2 times 22 times 14. Then put it all into my calculator. Remember, in the calculator, I want brackets around the top and I want brackets around the bottom. Unless you can put it in as a fraction in your calculator, which is even better. So bracket 22 squared plus 14 squared minus 18 squared, close bracket on the numerator, divided by, open bracket on the denominator, 2 times 22 times 14, close bracket on the denominator, enter, we get cos A equals 0.5779, ... We want A, not cos A, so we do A equals cos inverse of 0.5779, ... Second cos, second answer, enter. We get A equals 54.6954, ... So A equals 55 degrees. In triangle ABC, side A equals 9, side B equals 7, and angle C equals 33.6. Sketch a diagram and find the missing side and angles to the nearest tenth. Draw your oblique triangle. This triangle is ABC, so pick an angle to start at, call it A, then B, then C. Side A would be here, it equals 9. Side B would be down here, it equals 7. So definitely my triangle's not to scale because side B looks bigger than side A. Angle C is 33.6 degrees, and we want to find the missing side and the angles. So we're solving this triangle. That's what it means to solve a triangle. Start with finding side C. We don't have a full pair, so we can't use sine law. It's an oblique triangle, so we need to use cosine law. We're solving for a side, which is the formula a squared equals b squared plus c squared minus 2bc cos A. In this case, we're solving for side C, so we're going to rewrite that as c squared equals a squared plus b squared minus 2ab cos angle C. Then we plug in our information. C squared equals A is 9, 9 squared plus B is 7, 7 squared minus 2 times A, which is 9, times B, which is 7, times cos angle C, which is 33.6 degrees. Plug it all into our calculator. 9 squared plus 7 squared minus 2 times 9 times 7 times cos 33.6. Double check it. 9 squared plus 7 squared minus 2 times 9 times 7 times cos 33.6. Looks good. Hit enter. We get c squared equals 25.0519 ... We don't want c squared, we want c. So we take the square root of both sides and we get c equals second square root, second answer, enter, 5.0051 ... We'll round to the nearest tenth, it says. So we get C equals 5.0. Then we want to solve for angle A and angle B. Now that we have side C, we now have a full pair. C and C. So we can use Sine Law. Let's solve for angle A. Using the Sine Law, which is sine A over side A equals sine B over side B. Angle A is what we're looking for, so sine A over side A, which is 9, equals, the pair we have is C, sine angle C, which is 33.6 degrees, over side C, which we just calculated. Now we want to use the unrounded value here, 5.0051, because we want to be more accurate. If we use 5.0, our A value will be a little less accurate. So use at least 4 numbers after the decimal. Next, we are going to cross multiply and then divide. Bring up our calculator. Sine 33.6, move out of the brackets, times 9 divided by 5.0051, and we get sine A equals 0.9950 dot dot dot. We want A, not sine A, so we do A equals sine inverse of 0.9950 dot dot dot. Second function sine, second function answer, enter, and we get A equals 84.3197 dot dot dot. Rounding to the 10th as the question asked for, we get 84.3 degrees for angle A. And then last, we need to solve for angle B. We already know angles A and C, so we can use the property that the 3 angles in any triangle add to 180. Solve for B. B equals 180 degrees minus angle C, which is 33.6 degrees, minus angle A, which is 84.3197. Again, use at least 4 numbers after the decimal to get a more accurate result. Then we have angle B equals 180 minus 33.6 minus, and then I can do second function answer because my angle A was my last answer. Then I get 62.0802 dot dot dot, and round to the tenths, I get 62.1 degrees for angle B. There we go. We solved the triangle, we found the missing side and the 2 missing angles. And that brings us to the end of the Chapter 2 notes.